always represents a power. All right, so let me say that again. A coefficient in front of a logarithm always represents a power. So this is log z to the 1/3. And then, of course, plus log w. Now, who remembers what to do? Because my job, I need one logarithm. I need to combine this into one thing. What? Exactly. Marley remembers that when logarithms are added, they go together as a multiplication. If we had a problem where they were being subtracted, they would go together as a division. Now, if you are at all uncomfortable with this, you can rewrite that if you want to. You don't need to. How could this be rewritten if you didn't really like the way it looked?
The cube root of z.
Cube root of z. So if you rather, this is completely optional, but if you rather write it this way, that is fine. Z to the 1/3 means the cube root of z. Perfect. All right, here we go with z. All right, let's look at that for a moment. What do you think?
It's going to be division.
There's going to end up being a division, but first I got to take care of something else. What do I need to take care of first, Marley?
It's going to be log x to the 4th, y to the 4th.
Yeah, I gotta take care of this and this. Now they are coefficients in front of a logarithm. Coefficients in front of a logarithm always, always, always represent powers. So Marley says I have log x4, y4. Is that okay with everybody, that 4 goes with the x and the y?
Could you just keep it as x, y, 4?
You could, but in a minute I'm going to have to reduce, so I think I'll just go ahead and distribute it. But you're right, you could keep it that way. And then this will be minus log x cubed. So that's step 1. Everybody good? Now I'm going to put it together and write one logarithm. We've already decided it's going to be a division. Why is it a division? Because that's a subtraction. So we're going to have that guy over that guy. And now we can reduce because we have 4 x's over 3 x's. So we know that will reduce. And we'll have x, oh, I guess no fraction anymore. Just xy to the 4th. How about e? Can you do e? Remember your job, put them together. Log of 28. Is there anybody that's confused where she got the 28? She got the 28 from multiplying 7 times 4. And why did she multiply? Because the logarithms were added. What about f?
Log of 2.
The log of 2. And why is it the log of 2? It was really the log of 16 over 8. And it was 16 over 8 because the logs were subtracted. And when you put them together, they become a division. Good. How about g?
Log 8 over 19.
Other way around. 19 over 8. So ln 19 over 8. Now before anybody starts getting panicky, remember ln is just another symbol for log AC. So ln works just like every other logarithm. ln is a logarithm. It works just like log. And then h is a little bit harder. More stuff going on. All right, so how did you start? How would you start this one? What would you do first? Yeah, you got to take care of these guys first. Always, always, always take care of these guys. Okay, So this is gonna be ln, okay, now wait, if I put a 3 up here, that's gonna be 2 cubed, right?
8.
Can I just write 8? Is that too much? 2 cubed? Ethan, you okay with that? Now, same thing here. If I put a 1/2 up here,
6.
I'm gonna have ln 36 to the 1/2. But what does 1/2 mean? Square root. So this is just going to be 6. And then I'm gonna put them together. Have 1 ln, just 1.
48.
48.
Would you have to write that as log of e to the 48?
You could, but you don't have to.
Can you keep that?
Oh, yeah, yeah, ln is the correct notation, but if you changed it to RBC, nobody would care. Now, look at problem 2A. You are gonna do exactly the same thing, only opposite. So instead of putting it together, you're going to pull it apart. So, notice it's ln x times y. If you split that apart into 2 ln's, it will be ln x plus ln y. And why is it a plus when I pulled it apart? Because it's a multiply when it's together.
Wait, so you expand and write as a single?
They're opposite each other.
Yeah, but those are like the only two ones.
Yes. Yes. All right, how about B? What are you gonna put down as the answer to B? Log x minus log y. What do you think? Is everybody on my page here?
Okay.
Easy enough? All right, let's look at C, because it's a little bit more. Okay, good. This is a 2-step process. Gabby's done it all in one. You can do it in one if you want. But step 1 will be, let's separate it. So it would be log x cubed minus log y to the 4th. Now, why is it coming apart as a minus? Because it's a division. Does everybody understand why I didn't just grab these numbers and pull them out in front right now? The 3 has to go with just the x, and the 4 has to go with just the y. So before I can pull that number off, I have to separate them. Now I can pull it off. So 3 log x minus 4 log y. Remember before we were taking these numbers and putting them onto the thing as exponent? Now we're taking them off. And they're becoming coefficients.
So on the test, will we have to write that first step out, or do we just
No,
go straight to
you
the
can go
answer?
straight to here.
Okay.
I mean, that's a lot for being like our first day talking about this, but if that makes sense to you, it's fine. Absolutely fine. Okay, what about the next one?
Log of x, y to the 1/5.
Okay, that radical is a 1/5 power. Radicals do not live well in logarithm land. So whenever we see a radical, we usually change it right away. So instead of having a 5th root, I'm gonna write it as a 1/5 power. And the reason we do that is because now it's a power, and what can we do with powers? Move them. So this is gonna be 1/5 log xy.
So you wouldn't have to separate the x.
Oh, I do, I'm not done yet. Now I need to pull it apart. And when I pull it apart, it'll be 1/5 log x plus 1/5 log y. Does the 1/5 have to go with both of them, kids? Mm-hmm. Now, if you like it better, you could write it this way. 1/5 parentheses log x plus log y. That would be perfectly okay too, if that makes more sense to you. but the 1/5 does get attached to both of those. Okay.
If
Oh
we,
boy.
like the second step right there where it says 1/5 log xy, if we write it as 1/5 log, we put parentheses around x plus 1/5 log parentheses on y, is that different? Or is
Okay, so the first thing I want to do, I don't like this radical and logarithm land, so I'm going to get rid of the radical. So I'll write that as x to what power? 1/4. Okay, so now I've gotten rid of my radical. Okay, now what? I need to split it up, and when I split it up, it's going to be split as a subtraction. So it's going to be the log of the top minus the log of the bottom. Now what happens to the 1/4 now?
Move to the front.
Does the 1/4 have anything to do with the z? No, it's not like that other one. The 1/4 must go with the x. Now, some of you guys are really sharp. Did some of you go straight to here? That's okay. But make sure that 1/4 is only on the x. Anybody want to hazard a guess at that? Okay, Gabby says 1/5 log x minus 1/5 log y. Now, here was the original problem. Where in the world did those 1/5 come from? The 5th root is the 1/5 exponent. You are not going to be able to forget that, kids. You have got to remember, roots are fractional exponents. So a 5th root is a 1/5 power. Now, she put that 1/5, look at her answer. She put that 1/5 with the x and the y. Should she have?
Yes.
Yep, this time it goes with both, right, Joseph?
Yeah.
You understand, Joseph, why she put a minus sign in there?
Yeah, because
Why? Because it's a division. And when we split up divisions, we split them up as subtractions. Good. Oh, this one's tricky. I put this one in here because there's a couple in your homework like this. You're looking at that saying, well, that's not tricky, Mrs. Ford. That would be the log of 100 plus the log of x squared. Did you agree with that? Did anybody pull this 2 out in front? Oh, I hope not. Because that 2 only goes with the x. So you can bring it out in front here, but it doesn't have anything to do with the 100. Now here comes the tricky part. Again, this is tricky, but it's in your homework. What's the base on LOG? 10. So normally I don't write that in there, but I'm going to this time. Log base 10 of 100. What's special about 100? It's 10 squared. So this is the log base 10 of 10 squared. Who remembers what the log base 10 of 10 squared is?
2.
The answer is 2 plus 2 log x. I know, it's tricky.
So we always have to.
If it reduces, you're supposed to reduce it. Now, is Mrs. Ford going to deliberately try to trick you?
Yeah.
No.
Mhm.
I don't do
Just take off like 1/8.
It'll be a 1/8.
Object.
All right, one more, and then we're going to do something different. Here we go. All right. See that 3 right there? You gonna pull it out in front? not till you split these, and when you split them, it'll be ln 30 plus ln e cubed. You okay with that? Now wait a minute. What's ln stand for? So this really says log base c of e cubed. What's the log base c of e cubed? 3. There's the answer to this one. It's another tricky one. So this concept right here is a review. We spent one whole day doing a bunch of problems that were like log base 7 of 7 squared, which is 2. And log base 8 of 8 to the 1/2, which is 1/2. Remember that? We did a whole day of that. It's been like a week and a half ago now, but okay. All right, now get your calculators out, because now we're going to do some problems with our calculators. Notice none of this we needed a calculator for, but we're going to need a calculator to do. Okay, everybody ready? All right. Our job is to evaluate this. Now, so let me tell you right now, look at your logarithm buttons on your calculator. What are your logarithm buttons? Base, they're LOG, which is base 10, and LN, which is base E. Do you have a button on your calculator that does base 3? No. We're going to fix that. So here's what I want you to do, 72x. Now we're going to rewrite this equation. Everybody remember how we rewrite it? 3 to the x equals 4. Okay, you with me? Now something special is going to happen, but I need you to stay with me. Now I want you to take the logarithm of both sides. So up here, I got rid of the base 3. I rewrote my problem as 3 to the x equals 4. Now I'm going to put a new logarithm on both sides. But the new logarithm I'm putting on both sides is one I have on my calculator, LOG. See this guy? He's an exponent. What happens to him? He comes out in front. So x log 3 equals log 4. Remember, when you take the log of something to a power, the power becomes an exponent. So now I'm just going to divide, and x, the answer to the question, is the log of 4 divided by the log of 3. Now it's awfully quiet. I'm sensing some confusion. Let's go ahead and type it in, and then we'll do another one. Because I'm solving for x. I have to get x by itself. So I'm going to divide both sides by log 3. So I have x by itself.
Oh, Lordy.
So let's type on our calculator log 4. Now, as soon as you hit log, you get these parentheses. Make sure you close them. Divided by log 3. Did you get 1.26? Are there any rounding directions? Oh my,
Got one.
here is 10,000. That's 4 places, so I need a couple more. So 2619.
I got one.
Then you didn't type it right. Type log 4, close the parentheses.
Got the 4.
Oh, that'll work, that'll do it, yep, move the number, log 4 divided by log 3. Alright, let's look at B, number 7, or B, log base 7 of 11. Can you go through exactly the same steps? Log base 7 of 11, alright, so what's step 1? How did we start?
7 to the power of x equals 3.
Beautiful.
Use the log of both of them.
Then we take the log of both sides,
Put the x.
put the x in front, so we have x log 7 equals log 11, so x equals the log of 11 over the log of 7. The steps are very, very simple. So log 11 divided by log 7. Did you get 1.2323?
Yes.
If we round it off to 4 places? You got a calculator, Ethan? You typing it in? Probably should, just to make sure you know how. Alright, this is the last one we're gonna do together, and then I'm gonna have you try some on your own. They're all exactly the same. Here we go. Log base 0.4 of 12. Step 1. 0.4 to the x equals 12. Log both sides. So log 0.4 to the x equals log 12. And the reason that you did that is so what will happen? The exponent is going to come out in front, and then you can divide. So log 12 divided by log 0.4. I think I'm going to get a negative number. Negative 2.7119. Now, I didn't want to erase any of this because I was hoping that maybe if you pause a minute and look at the original problem and what we ultimately typed into our calculator. Do you notice anything? Here's the original problem, and this is what we ultimately typed in. Original problem, typing in.
It's all right there.
I was gonna ask that on the first one, but I was kind of lazy.
What do you notice?
It's all right there.
So when I look at problem D, for example, what do you think the answer might end up being?
Log of 3 over log of
Log of 3 over log of 29. And E will be log 18 over log 5. And F will be log 90 over log 2. Now you're saying, Ethan's saying Miss Ford's going to call me lazy. That's actually called the change of base formula. It's a formula. It will always work. If you can remember that when you see something like log base 15 of 11, that will always, always, always equal the log of 11 over the log of 15. I kind of remember it because when I write this, isn't this number higher than this number? I mean, above, written above. Isn't that number written above this one? So when I set up my fraction, it's the same way. That number over this number. The bottom number stays in the bottom.
Can I get your answer?
Is it an emergency?
Yes.
All right, hurry up. Okay, so we always have the formal strategy to work it out. But if we can remember our change of base formula, that will always work also. It's not being lazy. It is if you forget it.
I can think of it as like,
Go ahead and show us. This is a good idea.
Think of it as what?
you just like put like a division sign like right above the 15. Like write the whole.
Here? Okay. All right. Well, now I see I've got to use something in my book. So let's look on page 318 at problem 54 and see what's going on. Oh, this was a test question on the academic kids test. Let's see if we can figure it out. The homework question, number 54 on page 318, says I have this equation. I don't have to remember that, it's given to me. Oops. And it says I is the intensity. It tells me in the words there, intensity. And X is the depth. In my superior. Okay. Anyone besides me have a book open? Thank you, Robbie. Oh, and here's one. So Bailey, in this entire class, there's 2 books. Is that what I'm saying?
I left mine at home. Why is that?
Think maybe you ought to get it out?
It's too late for that. It's up.
Cohen's got one. You guys, that is lazy.
So I was doing my homework with that.
You can't follow along if you don't have your book open.
Sitting on the nightstand.
I'm sure.
That's where I do my homework.
Weren't you lighting your fire with it last time?
It's so messed up.
Well, I'll tell you one of the most
Sunday night?
heartbreaking moments in my career. This is a true story. I'm telling you one of the heartbreaking, sentimental moments in my career. It crushed my heart. It was the last day of school, and this kid walks in with this baggie full of ashes. And he handed it to me, and I said, "What is this?" He said, "Oh, you know what it is." No idea. And he proceeded to tell me it was his math book.
That's so mean. Who was it?
Isn't that mean?
Who was that?
So guess what I did?
You bought him a new one?
No.
You don't know?
I cried. I just sat down and cried. I was so sad.
Who was it?
Oh, never mind. It was a boy.
I mean, I assume that.
How long ago were you talking?
I was next door in the classroom, so it would have been, I don't know, probably the 2000s, early 2000s.
That's so mean.
Okay.
Did you have a good relationship with that kid?
I mean, I don't think I think he thought it was funny.
I think
He
it was
thought it was
intense.
some kind of a joke.
I think it was
I mean, I'm not saying we were best friends, but I don't think he hated my guts or anything. I mean, I don't know. He never indicated he did. But it was pretty mean. I think he thought it would be some funny joke. But even when he did it, the other kids in the class didn't laugh. I mean,
Really?
they knew. Yeah. Well, I was crying.
I know that.
Would you laugh if I were crying?
No, I would not.
Okay. All right. Now, here we go. They give me an equation. They tell me what the variables stand for, and then they tell me that I am looking for the intensity at a depth of 10 feet. So what am I going to do if the depth is 10 feet? I'm going to put 10 in for X. So now I'm going to have this equation. I'm going to put 10 in. So I'm going to multiply. So this is what I have. This is the equation that I have. Now my job is to figure out what I is. This is trouble. because I got this logarithm here. Now what's the base?
10.
The base on the logarithm is 10. How do I know the base on the logarithm is 10? Because log always means 10. Now, I'm going to rewrite this equation. How could this equation be rewritten? 10
To the
to the negative 0.125 equals I over 12. Remember the translation formula. This to this power equals this every time. So 10 to the negative 0.125 equals I over 12. Can I type 10 raised to the negative 0.125 on my calculator? Yep. So type 10 raised to the negative 0.125. And then what are we going to have to do to get I by itself? We'll have to multiply by 12. So the answer to this question is 8.99. Well, actually, I'm going to say about 9 because it's very close to 9. And the unit on that's what, lumens? Alright, there's another one. Let's see if we can do another one. 52a on the same page. Now, this is a different equation. You don't need to worry about these equations. You'll be given them. There are a couple you'll have to memorize, but not these weirdos. Okay, let's see what everything stands for. It says A is the amplitude. It says T is the period. And B is something. And we're supposed to compute R, find R. This is, they tell me what it is. What is it that counts? All right, so here we go. Let's see if we can answer this question. 52a. Did you notice they give me an A value, a T value, and a B value? So R equals the log of 250 over 2 plus 4.25. Kids, that looks hard, but they gave me all of these values. I mean, they just said here they are, so I just plug them in. Now what am I going to do? Go to my calculator, and I'm going to press log. I can either do 250 over 2 or just do 125. It doesn't matter. Be sure you close the parentheses. And then plus 4.25. And that earthquake magnitude is 6.35.
Oh my.
Approximately.
The big one. Oh, the R is the Richter scale.
I understand.
Alright, here's what's going to happen now. We're going to quickly do this next section, A through I, because these we can do with no calculator. And then I'm going to pass back your tests, and then we'll finish up with the calculator part at the bottom. So here we go. A. Stay with me. We're going to do these 8 problems. They're easy, especially A. You ought to be able to look at A and tell me the answer is 3. 2 to what power is 8? You guys, come on. 3. Yep. Now B is a little bit trickier, but not very much.
2.
Now, those of you that said 2 are right on. Here's what I want you to think about. start the problem by dividing by 3. So 4 to the x, what's 48 divided by 3? 16. So 4 to what power gives me 16? 2. So we started by getting rid of that extra number. Now, C, you're looking at that saying this is 4, that's not possible.
Cool. Is the answer x equals 2 or just 2?
And the answer is x equals 2. Okay. You guys. Alright. 4 to a power is not 8. Like 4 to the first, 4 to the second, 4 to the third is not 8. However, 4 is 2 squared and 8 is 2 cubed. So instead of thinking about it as 4 and 8, I'll think about them as both powers of 2. Now, 2x equals 3. So what does x equal? 3 halves. Not 3 1/2, 3 halves. And I got 3 halves because I thought of 4 as 2 squared and I thought of 8 as 2 cubed. Now, I didn't have to do that in this problem. I could say x is 2 here because 16 is actually a power of 4. It's 4 squared. 8 is not a power of 4. So I need to break it down into 2's. All right, D. Think about what we did over there. Divide by 3. So 4 to the 2x equals 32. All right, now wait a second. 32 is not 4 squared or 4 cubed. It's not 4 to anything. However, 4 is 2 squared, and 32 is 2 to the 5th. So once again, 4 and 32 aren't powers of each other, but they are both powers of 2. What's this? 4x equals 5, so x equals 5 fourths. You're thinking, oh my gosh, what's this for? And I'm never going to be able to do that on my own. Yeah, you will. You just have to keep practicing. Marley, did you have a question, sweetie?
No, never mind.
2 times 5 to the x over 3 equals 250. Step 1, divide by 2. So 5 to the x over 3 equals 125. Now, is 125 5 to something? It's 5 to the third. So 5 to the x over 3 is 5 cubed. So that means that x over 3 is 3, which means x must be 9. Maybe we'll just do one more and then we'll pause for a moment. All right, how about F? What are we going to do with F? Yep. Now, if you're not paying attention, then you aren't dividing by 2 like you're supposed to. You've got to get rid of that number. So 9 to the x plus 3 equals 27. Is 27 9 to a power? No. No. However, 9 and 27 can both be written as 3 to a power. So this one is 3 squared. And this one is 3 to the third? When they're not powers of each other, you have to break them down to a smaller number. Alright, so what's this? 2x plus 6. I love it, that's right. 2x plus 6, that's a distribute. Equals 3. So 2x equals negative 3 and x equals negative 3 halves. Alright, that's a lot of stuff. We got this section to finish. Maybe you can go ahead and finish it. Chris, would you turn that off on the way to turn your test down?